In this video, I am going to explain Routing Information Protocol or RIP in the iOS XR. But first, I want to review some of the topics related to this routing protocol. Then we will learn about the configuration of RIP in iOS XR. RIP is a UDP-based distance vector protocol that broadcasts routes using port number 520. And RIP sends out the routing updates at an interval called the route update interval every 30 seconds. It expects the neighbor to send the update with the same frequency. Routing updates are also sent in the event of any network change. RIP supports different timers, specifically a timer to control the frequency of the route update and a timer to invalidate a RIP route. This video describes fundamental concept and the differences between RIP version 1 and RIP version 2 before explaining how to configure RIP for iOS XR. RIP uses a simple hop count as a metric to compute alternate paths and is limited to networks with a diameter of up to 15 hops. A route advertised with distance metric of 16 is marked as invalid and considered unreachable. This value is called infinity because it is larger than the maximum allowable value of 15 for the protocol metric. RIP is generally not the best choice of routing protocol, especially when intelligent route update and calculation method that can incorporate link characteristics for metric are desired. Unlike other IGP protocols, RIP does not form neighbor relationship or adjacency. Passive configuration command is used in conjunction with RIP to prevent routing updates from being sent out on a given interface. However, RIP continues to receive routing updates through the interface from its neighbor. Now let me to explain a little about the RIP versions. Currently, two versions of RIP exist, RIP version 1 and RIP version 2. Both of these two protocols actually can carry maximum of 25 routes in the protocol packet headers. RIP version 1 does not support any subnet mask. In the absence of subnet mask, RIP version 1 advertises class full subnets if network addresses fall or at major class boundary. If the network addresses do not fall at the major class boundary, the subnet mask of the interface closest to that network address is chosen. RIP version 1 does not provide any security against any malicious attacks. There is no check in RIP for the source of the route received by the router. Now let me to explain about the RIP version 2. Before that, look at here. RIP version 1 is a class full protocol. RIP version 1 use broadcast for updates. RIP version 1 broadcast update every 30 seconds, and RIP version 1 does not support variable subnet mask or VLSM, and finally RIP version 1 does not support authentication. About the RIP version 2, it eliminates some of the constraints seen with RIP version 1 because it supports features such as routing domains, external route tags, route summarization, route distribution, variable length subnet mask or VLSM, next hop addresses, and authentication. Authentication support exists for both clear text and MD5, and hence it is a significant improvement over RIP version 1. In comparison with the broadcast update of RIP version 1, RIP version 2 packets might be multicast as well. The use of a multicast address 224.0.0.9 reduces the unnecessary processing load on network devices that do not support RIP routing. RIP is a stable, simple, and easy to configure protocol that is compatible with wide varieties of network devices and is still widely deployed in legacy and small or stub networks. iOS XR by default support RIP version 2, and here you can see the criteria of RIP version 2. RIP version 2 is a classless protocol. RIP version 2 uses multicast for updates. RIP version 2 support triggered updates when a change occurs, and RIP version 2 also support VLSM. Finally, RIP version 2 support authentication and more. Alright, now let me to explain about the configuring RIP in Cisco IOS XR. As a first step, IOS XR require building a target configuration. After the target configuration is built, the user needs to issue an explicit commit to add it to the running configuration of the router. RIP configuration is simplified in IOS XR. Unlike iOS, where network addresses are configured under RIP protocol configuration, in iOS XR only the interfaces that are participate in RIP are configured under the routing process. And the RIP process gets started the moment RIP is configured on the router. After initializing of the process, the configuration is parsed and find interfaces that need to be enabled for RIP. And here we have this scenario, and actually this scenario shows a setup that has two routers connected back to back over 1 gigabit Ethernet interface, and also here we have a loopback in the router 1 and another loopback in the router 2. And now we want to configure this scenario from the scratch. Before configuration, let me to explain that in some iOS XR, routing protocols can be configured before actually the interface are configured with the IP address. It means that you can configure RIP and then IP address of the interfaces. However, the routing protocol becomes active only after the network address is configured on at least one of the interfaces. Let me to configure this scenario from the scratch. This is our CLI in the router 1 and router 2. Now we don't have any configuration. Configure terminal, and then host name is for example R1XR. As you know, I didn't commit the configuration. Because of that, now the host name is iOS. Also here we have two interface. The first interface is interface gigabit 000, and the IP address of this interface is 10.1.2.1. Let me to configure it. IPv4 address 10.1.2.1/24. Okay, and then we should enable the interface with the no shutdown command. And the next interface is the interface loopback 0. Let me to configure it. Interface loopback 0, IPv4 address quad 1/32. And then we can go to the router 2. In the router 2, we use the similar configuration, host name the R2, and then interface gigabit 0000, IPv4 address for example 10.1.2.2/24, and no shutdown. And after that, interface loopback 0, IPv4 address the quad 2/32. Now we can commit the configuration in both routers, router 1 and then router 2. Okay, you know that until now I didn't configure the RIP, but actually now we expect to have connectivity between the R1 and R2. Ping in router 1, ping 10.1.2.2. This is the IP address of the gigabit 000 of the router 2. Also in the routing table of the router 1 show route, we have one connected interface, network 10.1.2.0/24, and also one local actually quad 1/32. And after that, in IOS XR, you know that for /32 we will have only the local network, not connected network. Also in the router 2 we have similar condition, show route. Show route can show us similar networks, first one connected and two local, one for gigabit 000 and one for loopback 0. Yeah, now we don't have any connectivity between the quad 1 and also quad 2. Let me to configure the RIP. It is so easy. Actually now I want to enable RIP on loopback and also gigabit interface, okay, and in router 1 and router 2. For configuration of RIP, we should go to the global configuration mode, and here you have this command router rip. So easy. Look at here. This is the command that we need. And here you can see one difference with iOS, config RIP instead of config router in iOS. And then here only you need to use interface and then the name of interface. That's it. Here we don't have network command actually. Interface gigabit 0000, the first interface, and second interface, for example, loopback 0. That's it. But we should commit the configuration. Let me to commit the configuration. And after that, here in the router 2, again, we should configure similar commands, router RIP, okay? And then, for example, interface gigabit 0000, and then interface loopback 0, finally commit the configuration. That's it. This is the configuration of RIP in the iOS XR, and how we can monitor it I will show you, but for now let me to show you the show running config. You can use show running config, then router RIP. What does it mean? It means that please show me the RIP part of running configuration, or the router RIP part of the running configuration. Here you can see this is the configuration of RIP. Router RIP, interface loopback 0, and then interface gigabit 0000 in the router 1, and also in the router 2 show running config, then for example router RIP. Again here we have the similar condition. All right, now we can check the connectivity between these two loopback, or if you want you can use show root command. Show root or do show root command can show us that here now in the router 1 we learn quad 2, okay, and everything is same with the iOS. Quad 2/32 administrative distance of RIP is 120, metric is 1 because here we have one hop count. Next hop is 10.1.2.2, and then the outgoing interface is gigabit 0000. In the router 2 also do show root can show us that we have similar condition. Let me to check the connectivity. We can use ping command, ping to the quad 2 with the source of quad 1, okay, and here as you can see we have connectivity. Actually now we know how we can configure RIP in iOS XR. Alright, now let me to explain about the configuring route policy language, or RPL. Route policy language, or RPL, is used in conjunction with RIP to perform different functionalities. It can be used to set, for example, different metrics during redistribution, or to filter routing update from neighboring routers. There are two options in RIP to change the RIP metric: set RIP metric, which change the metric of the route to the newly configured value, and add RIP metric option, which update the original metric by an offset defined as per the configuration. Let me to show you, it is interesting. First, let me to configure one static route in the router 1. I want to redistribute this static route to the RIP, and then I will use the route policy language for changing the metric. It's interesting. Look at here. In the router 1, first we need one static route, and here I want to use this command router and then static. Okay. After that, address family IPv4 unicast, and then a network quad 3/32. With the, then for example, outgoing interface of null 0. It's not important, it's only a static route for us in this scenario. And then commit the configuration. Now here we have one static route inside the routing table of router 1. As you can see here, we have this static route. Now let me to configure the redistribution inside the router RIP. Look at here, when you use redistribute static and then commit the configuration, here in the router 2, as you know, show root doesn't show the quad 3/32 to us. Why? Because in RIP we need to configure the metric, actually redistribution metric, or the seed metric. Let me to configure a route policy. Here we can configure the route policy command. Route policy exactly same with the, or so similar to the route map. Here, for example, the route policy name is A. Route policy A. Now we are under the config RPL. Here you can configure now the set RIP metric, for example, and a value between 0 to 16. For example, let me to configure the 5. Okay, and then commit. Now we have a route policy. Here you should use end policy. We have a route policy after commit, and then in show RPL can show us that the road policy name is A, and the rule is or the set condition is set rip metric 5, and then end policy. That's it. Now let me to use this road policy like the iOS. Router RIP redistribute static according to the road policy, for example A, the name of road policy, and then commit the configuration. Now we expect to see the quad 3/32 in the router 2's routing table with the metric of 5, because we configured set metric 5. As you can see, now we have this route, and because in RIP we don't have any type of external internal networks, here we have only quad 3/32. It is interesting. Alright, now let's configure the prefix set to filter a specific route from the database. Actually, I want to show you the other function of route policy. Here in the router 1, first let me to remove the redistribution command in the router 1. Now configure terminal, router RIP, no redistribute static, and then commit. Okay, and after that, here now we expect that in the router 2 we have only the route learned from routes, for example quad 1/32, and here we don't have quad 3/32. Now let me to add one loopback interface. For example, in the router 1 I will configure interface loopback 1 with the IP address of IPv4 address of 1.1.1.2/32. Now here we have two loopback interface, okay, quad 1/32 and 1.1.1.2/32. Okay, let me to add this interface inside the RIP, router RIP, interface loopback 1, and then commit. Here, as you can see in the router 2, now we have this network show route 1.1.1.2. Okay. All right, now I want to configure one filter with route policy in router 2, and router 2 should accept only quad 1/32, not 1.1.1.2/32. It is so easy. In the router 2, first we should configure a prefix set. With this prefix set, actually we match the network that we want to pass, or we want to, for example, drop. Let me to use this command, prefix set. It is so easy. Give it a name, for example, A, and then which network you want to match. 1.1.1.1 means quad 1/32. That's it, and end set. That's it. Now you have a prefix set. Okay, let me to configure the route policy. The name of the route policy is for example AA, and here you have a route policy with if then function. If the destination means the network in the policy A, if destination in policy A means in prefix set A, then here we have multiple options, pass, drop, or some other things. Let me to use pass now. And after that, end if. This is the end of the if, and also end of the policy. That's it. Now we have a policy. Let me to show you. Here first we should commit it. Okay, and then show RPL can show us the prefix set A, quad 1/32 end set, and then route policy AA, if destination in A, then pass, end if, end policy. That's it. Now we can use it under the router RIP. You know that before applying this policy in the routing table, we have two RIP learn routes, okay, quad 1/32 and 1.1.1.2/32. Let me to use this command, router RIP, then route policy. The name of route policy is AA, inbound direction. This is so similar to the configuration of route map, okay, route policy AA in. Because this is the RIP, maybe you need to wait some second, or if you want, you can use clear RIP database to faster convergence. Let me to use the in the router 2 clear RIP database. Okay, and now we can check the show route. Here we have only quad 1/32. Look at here, show RPL can show us that this is our prefix set A, include quad 1/32, and after that route policy AA, if destination in A, then pass, and other networks should be denied. Also here in the show running config router RIP, you can see that we have this configuration, route policy AA in inbound direction. Because of that, now you know about this configuration. Also, we have one other option in the route policy, add RIP metric. You can add to the metric of some networks. For example, here, you know that we configured in the router 2, configure terminal, route, then policy AA. And here we configured if destination in A, then pass. Okay, beside of pass, you can say add, and then for example RIP metric, for example 3 or 4. Okay, and then here end if, and after that end policy, then commit this policy. Okay, in the routing table show route, you can see after, let me to use the for example clear again RIP database. Okay, and then show route now can show us that the quad 1/32 learned with the metric of 5. Actually, we added to the metric of the learned routes 4 value. Okay, add RIP metric. This is the next option. Also, until now, we used their route policy. Don't forget, route policy is like roadmap, and you will use it in many features in many routing protocols. The next feature in RIP is configuring passive interface. Passive interfaces in RIP do not advertise routing updates. And let me to configure one interface as passive. In this scenario, it's not so useful. But for example, let me to configure interface of R1 as passive interface. In the router 1, we can configure these commands. Again, we should go to the router RIP. So easy. You know that which interface is passive. For example, gigabit 00. Interface gigabit 0000. Let me to configure passive interface. That's it. And then commit the configuration. In the router 2, we expect to that we shouldn't learn any networks from the router 1 now. After, for example, clear RIP database and then show route, you can see that we don't have quad 1/32 or 1.1.1.2/32. Because of that, this is the next feature. But in this example, it's not useful. Because of that, let me to remove it. No passive interface. Again, commit. And here in the router 2, show route, or after clear RIP database, show route can show us that we have quad 1/32. All right, now let me to explain about some other features related to the RIP. For example, restarting, shutting down, and also blocking RIP. RIP is defined as a cold restart process because the RIP process on the standby root processor is not fully initialized. Okay, the RIP process can be restarted, shut down, blocked, or started, and it can use the checkpoint recovery mechanism of iOS XR to recover. RIP is non-stop forwarding NSF aware, and therefore it can be restarted without impacting data traffic or RIP routing information base. It can be monitored using the show process RIP command. Let me to show you, actually, in this example, I will provide the iOS XR commands to restart, shut down, and block the RIP process. Okay, the show process RIP command is used to know the state of the process and to know the job ID that can be used in conjunction with other commands. The first command is the show processes CPU, show process or show process RIP. As you can see, here we have this information. Job ID is 1024, and also here we have as many other information. The process state is important. As you can see, the process state is run. Okay, a RIP process can be restarted, shut down, or blocked using the job ID. Okay, job ID or the RIP keyword. As you can see in this example, look at here, you can say for example process, okay, process shut down RIP, or a process blocked, for example the job ID. Okay, here we can use both of them, the RIP keyword or the job ID. For example, process shutdown, the number of job ID is 1024. Let me to use RIP. Now, process shutdown of a process could leave the system in an inconsistent state. Proceed, yes, confirm. Okay, now as you can see here, we shut down the RIP, and then show processes show process RIP can show us that here this RIP has the state of the killed last exit to the system. Actually, we shut it down administratively. We shut it down. Also, you can restart it with, for example, let me to enable it. No process here. You can use process then restart it, or process restart RIP or the number 1074. Okay, and here as you can see, user admin request the restart of process, and with job ID 1024, and here in the show process, okay, RIP, we can see again the state is killed because we shut it down the RIP. First we should start it. We can use process start and then the 1074, okay, and then show process. Here RIP can show us that it is started. It is the state is normal and now it is working. Also, if you want, you can use again process RIP. Okay, here process restart and then RIP. Okay, RIP. Now this RIP is restarting actually. Show process. Okay, the RIP, or you can kind of use the job ID. Actually, both of them are same. Okay, actually we have three commands: process shutdown RIP, process restart RIP, and also process blocked. Also, we can use show process RIP detail command. Okay, actually this can show us the status of process running on a standby root processor. Look at here, for example, we can use show process and then processes RIP, then detail, then location. For example, the location is 0/RP0 and then CPU 0. Okay, CPU 0, and here as you can see here, we have the detail information related to the actually status of process running on a standby RP. Here we have many information. All right. Also, here we have some comments for verifying and troubleshooting RIP. Actually, I want to show you some of show commands that can be used to verify and troubleshoot RIP on iOS XR. First, let me to display the information for interfaces enabled for RIP and the version configured. It's interesting. Look at here in the router 1, we can use this command show RIP. Okay, show RIP, then interfaces, or show RIP interface. The name of interface is, for example, gigabit 0000. This command can show us that on this interface RIP is enabled, and the version of RIP on this interface is version 2. As I mentioned before, iOS XR support version 2 by default. Okay, and some other useful information, for example, interface state, IP address of this interface, and also a split horizon status and poison reverse status, and some other useful information. Here now we don't have authentication, we can enable it, and some other useful information. This is the first command, show RIP interface. Also, the next command is the command that you can use for monitoring or for displaying the topology database for RIP. Here in the router 1, you can use show RIP database. So easy. This is the database of router, the RIP in this router. And also for monitoring the routing table, you can use show root RIP. This is the only route that we learned from the RIP. Here we have the other command, show RIP statistics. Okay, statistics. And this command can show us the RIP statistics, total message sent failures, regular updates sent, queries respond to, and some other useful counters that we can use them for troubleshooting in most cases. Also, in RIP, because RIP support VRF, you can use show RIP VRF statistics command if you have VRF. Also, you can use, for example, a clear RIP. Clear RIP means clear the RIP database. Clear and then RIP. It clears the RIP database. We have some commands for debugging RIP, like the debug RIP, authentication, database, events, global, and some other options. Let me to show you here. Debug RIP, okay. And then the options is AUTH means RIP authentication, database RIP database events, events RIP protocol events, global RIP global message, HA means RIP high availability, IM means RIP VRF and interface events, init RIP initialization debugs, and some other useful debug command that you can use them. And also let me to emphasize that here I don't want to explain about the RIP itself, because the RIP is a routing protocol that we should learn about it in the routing courses. Here we are learning about the RIP configuration and also some RIP details in iOS XR. Because of that, we briefly explain the routing protocol, and also we show how we can configure the routing protocol in iOS XR.